Britain possessed a workable path to a new planet and still lost the discovery. In Berlin, astronomer Johann Gottfried Galle received a letter containing coordinates. That same night, he and Heinrich d'Arrest turned a telescope toward the predicted region of sky. Within hours, the planet Neptune was found. The discovery triggered one of the most famous priority disputes in scientific history. Because by the time Berlin looked through the telescope, Britain already possessed part of the answer. The question is not how Neptune was discovered. The question is how a discovery was lost before the telescope even moved. The story begins with numbers that refused to behave. Astronomers believed they understood the architecture of the solar system. Planetary motions could be calculated. Future positions could be predicted. The machinery appeared reliable. Then Uranus began drifting away from expectation. The deviations were small, not dramatic enough to suggest catastrophe, but they accumulated across observation records and orbital tables. Each correction fixed part of the problem while leaving a remainder behind. The charts themselves became evidence. Something unseen appeared to be pulling on Uranus. No telescope could see it. No one could point to it. Yet the orbital records kept returning to the same possibility. A hidden planet might be out there. Someone only had to calculate where. The hunt began in two places. In Britain, a young mathematician named John Couch Adams started working through the problem. He treated the unexplained motion of Uranus like a trail left behind by an invisible object. If the unseen planet existed, its gravity should leave clues. Across the channel, French mathematician Urbain Le Verrier entered the same pursuit. Neither man could observe the planet directly. Both were attempting something extraordinary, finding a world by mathematics before anyone had seen it. Sheets of calculations accumulated. Positions were estimated. Possible orbital paths emerged. And without coordinating with one another, both men moved toward the same hidden target. The race had begun. At first glance, it looked like a race of intellect. Who would solve the problem first? But that was not the real contest. The real contest would begin after the calculations were finished. Because a prediction on paper is not a discovery. A discovery requires someone to look. Adams produced results and sent them into Britain's astronomical establishment. Coordinates began moving through letters. And written calculations became correspondence. Correspondence became questions. Questions generated replies. And then the process slowed. The most important object in this story is not a telescope. It is a letter. Letters moved between Adams and Astronomer Royal George Biddle Airy. Questions were raised about details of the calculations. Clarifications were requested. Responses did not always arrive quickly. The coordinates existed. The opportunity existed. The telescope remained still. Every day preserved the possibility of discovery. Every day also consumed it. At this stage, Britain still possessed a future in which it became the nation that found Neptune. Nothing had yet been lost, but nothing had yet been secured. The calculations sat inside a system that depended on people responding, deciding, organizing, and acting. Possession of knowledge was no longer the central issue. Conversion of knowledge into observation had become the issue, and observation had not happened. Meanwhile, events in France were moving in a different direction. Le Verrier continued refining his work. More importantly, he made it public. Predictions appeared in published papers. Coordinates left private correspondence and entered the wider astronomical world. The hidden planet was no longer merely a theoretical target. It was becoming a public challenge. The meaning of the coordinates changed. Earlier, they represented a possibility. Now they represented a countdown. Every observatory capable of testing the prediction became a potential winner of the race. The opportunity Britain still possessed was beginning to escape British control. Delay no longer meant waiting. Delay meant competition. Leverrier understood something crucial. A prediction only acquires ownership when somebody verifies it. So he pushed outward. His calculations reached beyond France. Eventually, they reached Berlin. And there, unlike elsewhere, a second physical object changed the story. A star chart. The Berlin Observatory possessed detailed charts of stars in the region where Leverrier predicted the planet would appear. That mattered enormously. If observers compared the sky against the chart and found an object that did not belong, the mystery could be resolved immediately. The coordinates arrived. The telescope was pointed. The race entered its final night. On the evening of September 23, 1846, Gale and d'Arrest began comparing the sky against the chart. The process was simple in concept and unforgiving in practice. Every recorded star had to match. Anything missing would be suspicious. Anything extra could be extraordinary. The opportunity still existed. The prediction could still fail. The calculations might place observers near the correct location while missing the planet entirely. Hours earlier, Neptune had remained hypothetical. Hours later, they found an object not shown on the chart. A single point of light, close to the predicted position, not where the chart said it should be. The hidden world had appeared. Prediction became observation. The race ended. And at that exact moment, a new conflict began. Discovery seems simple until people try to define it. Was Neptune discovered by the person who calculated its existence? By the observatory that verified it? By the nation that first possessed a workable solution? Or by the institution that transformed coordinates into a confirmed planet? Britain pointed toward atoms. France pointed toward Leverrier. The observation records pointed toward Berlin. Letters were re-examined. Dates were scrutinized. Claims were compared. The same chain of events that produced Neptune now produced a dispute over ownership. History often prefers clean victories. This story resists one. Atoms genuinely produced important calculations. Leverrier genuinely produced predictions that directly led to observation. Gall genuinely participated in the observation that confirmed the planet. The controversy survives because the discovery itself contained multiple stages. Prediction. Verification. Recognition. They were not completed by the same people. The irony is visible in the objects that carried the story forward. The orbital charts revealed a problem. The calculations suggested a solution. The letters carried coordinates through institutions. The star chart in Berlin turned those coordinates into a target, and the telescope transformed the target into a planet. Britain's failure was not mathematical. That is what makes the story memorable. The calculations were never the decisive weakness. The decisive weakness was the gap between knowing and acting. At the beginning of this story, the unanswered question was how the side with part of the answer could lose. The answer was hidden inside the journey of those coordinates. They moved through letters faster than they moved through telescopes. And in a race where scientific priority depended on observation, that difference was enough. The discovery of Neptune did not belong to the first person who approached the solution. It belonged to the side that converted a prediction into a sighting before the opportunity disappeared. By the time the telescope in Berlin moved, the race had already been decided.